Alright, and we're back. We're continuing our talk on Chapter 8 on patch panels. Some of the next thing they mention is with patch panels, they need to meet connection standards for the category being used. If I'm using category 5E horizontal cabling, it should be terminated to a patch panel rated as category 5E. So as I work with my patch panels, I should be looking for the category rating. This patch panel is rated category 5, so look for that. And again, they're going to be marked in different places. Here's one rated 5E. This one's marked on the front. Look for it. Or I should say it's another place to look for it. These are category 6 marked on the front. These are category 6 marked right here on the outlet jack. So look for the rating on there and make sure it's matching the category of cable you're using. Going back to what we said almost week 1, horizontal cabling is category 6, patch panel should be category 6, outlet jack should be category 6, patch cables should be category 6. Everything should match. So, patch panels are no different. Just look for that rating and make sure you know that it is. Make sure it is there. Here's one that's category 6A, okay, because of the shielding. Workmanship. As I'm dealing with patch panels, I need to properly route and terminate my cables to the back. I need to route them and terminate them into my patch panel correctly. So one of the first things we talk about is routing. Typically, your cabling is going to come down the center of the patch panel and up into the patch panel 110 block, down the center of the patch panel and down into the patch panel block, if you will. That's typical routing, so I have this arrangement. What that allows me to do is put a switch or something right below it if I need to, or a patch panel, another patch panel, or another piece of equipment. So I'm typically going to route it down the center of the patch panel and then kind of turn up and turn down to terminate. Here it shows you on the back of this patch panel there's actually a bar here to help with supporting the cabling to do so. Here's a patch panel that even has a bar back here to organize the cabling so it's a nice even bend coming in. And you notice the patch panel is even bent. That way cables coming in are able to not have a sharp bend, and patch cables on the front won't have a sharp bend going out to the side of the rack and so forth. Here it is again, coming in the center of the patch panel, up and down as I'm terminating. Center of the patch panel, up and down. Properly route that cabling and terminate. As I'm dealing with, I need to watch my twists, kinks, and bends and so forth. That's where all the rounded corners come in and all the management panels, which we'll talk about in a minute. I need to watch the skewing of my wires. We mentioned this in an earlier chapter. I need to make sure my cabling comes in and does not, I don't have a real short wire pair here and a real long wire pair here. In this case, the bits are going to arrive at this termination quicker than the bits arriving at this termination. So I need to watch that. I need to make sure it's centered. This is a little more centered. Comes in and centers over my connection so all 4 pairs are roughly the same length as I'm terminating. I need to watch for that. I need to work in some wire management so that I can support my cabling coming into the back of the patch panel and support my cabling in the front of the patch panel. So I need to have raceways and other things above. I need rails on the side. I need vertical rails, probably horizontal rails and those sorts of things. So here's some wire management panels. Again, as we said in the last chapter, this wire management panel has little notches in the front so that I can add patch cables in and take them out. But I need a way to support them. And you'll notice that's a nice gentle bend going in there. It has to bend to get in there, but it's a nice gentle bend going in. It's supported the whole way into the patch panel or into a switch below it, if you will. And I use the same picture as before. I need trays above, some kind of trays above. I bring the cabling down into the rack, nice gentle bend, support it with vertical panel here, support it with a horizontal panel here, and in the patch panel. And the same thing would be going on in the back to support my cabling into the back of the patch panel. They mentioned connectorized patch panels. Not so common. Again, this is more kind of on the phone end of things, but I do actually they do exist where I can have the phenol connector connect into here. Again, I'm probably going into my phone switch, and this goes out to the front of the patch panel where I can be plugging in phone lines and that kind of thing. They do exist, not so common for our data lines. I need to make sure I'm routing and dressing in these as we previously mentioned. Keep my patches horizontal cable below the 5 meter length. Remember, we're allowed 10 meters for patch cables, so the closet I have about 5 meters to use. I have about 5 meters in the work area, so I need to keep them at a minimum. Only use what I need to connect together switches and patch panels and those kinds of things. I need to make sure I have a consistent method of labeling and terminating, or I should say labeling my terminations, labeling my patch panels, labeling my outlets, the whole 9 yards. Remember our 606 standard. I copied all this in again. I need to make sure I'm labeling my closets, make sure I'm labeling my cabinets, make sure I'm labeling my patch panels. There we go. Label my patch panels with identifier. Make sure I'm labeling all the ports on the patch panels. Make sure I'm labeling the cables. Make sure I'm labeling the equipment outlets. Make sure I have records of everything. That's key. Make sure I have records of all of my terminations. That way, again, it's going to aid me in troubleshooting, locating that port, locating the distance of the cable, that sort of thing. I have all that documented. I need to make sure I am following that. And again, as we mentioned before, having a good labeling scheme. I'm not going to use a super huge scheme. That is way too much information. It's not going to fit on a faceplate. I need something a little more compact, like we've said before. Some sort of maybe 2 or 3 number kind of thing. Labeling my building or my closet, labeling the room I'm wiring, maybe with the port on the patch panel kind of thing. That way, again, as I'm looking at this cable label, I know what closet it's going to, I know what room it's going to, I know what port the patch panel is going to, helping me with troubleshooting. Where is this thing going? They mentioned at the end of this chapter a little bit about patch cords, kind of getting us started, because my patch cords are in my closet. I have patch cords at the work area where my users' computers are, and I also have patch cords in the closet. So I need to start mentioning them. Most of my patch cables I'm going to deal with in my horizontal cabling and wiring of my building are going to be straight through. That's what most of them are going to be. They are going to be 4-pair, 24 gauge, 100 ohm, stranded wire. Remember, stranded, solid 4 horizontal cabling, stranded for my patch cables. Same kind of insulation we dealt with before, PVC. Remember, with stranded, we're going to add about 20% attenuation. We're going to have about 20% more attenuation in a stranded cable. That's one of the other reasons we keep our patch cables as short as we need them, if you will. I need to make sure I'm below the 5 or 6 meters for all of this, as we said before. I have roughly 3 that I will encounter. We encounter straight through, crossover, and rollover cables. Straight through is to connect unlike devices, PC to my outlet on the wall, PC to a switch kind of thing. Crossover that I'm going to use to connect like devices, connecting a switch to a switch, connecting a router to a router kind of deal. And a rollover cable. This is the kind that goes from the COM port on my computer to a console port on a router or switch. So if I take a look, my straight through cable, I know these are a little blurry. I took them with my the camera on my phone, but here's a wire map of a straight through cable, and what you're seeing is this is actually one end of my patch cable here on the left. Over on the right is the other end of the patch cable. So the meter's saying, okay, when I sent a signal in on this pin, it came out on this pin over here. So this is wired straight through. I used the same color code on this end as I used on this end, so I'm getting a straight through wiring. Almost all my wiring for our horizontal cabling systems we've been dealing with is going to be straight through wiring. The patch cable in the closet, going from the patch panel to the switch, is going to be straight through. The patch cable out at the user desk, going from the wall outlet into the PC, is going to be straight through, because that whole system is connecting a PC into a switch. If you think going from my PC into the wall outlet, horizontal cabling, patch panel, switch, I'm really connecting my PC into a switch, and those are unlike devices, so I'm going to use a straight through cable. So all my wiring pretty much that I'm going to deal with in our system is going to be straight through this kind of patch cable. We will make that in when we talk about chapter 9, but there's my straight through patch cable. Meanwhile, a crossover is used to connect like devices together. Well, real quickly, if I'm going to connect 2 switches together, example, maybe switch port 1 is transmit. Well, if I connect transmit port 1 on the first switch over to transmit port 1 or pin 1 on the second switch, I'm going to have collisions. So if I'm going to connect like devices together, I need to connect the transmits on one switch to the receives on the other switch. So what I need to start doing is flip-flopping my wire pairs. So again, here's a wire map of a crossover cable, N1 of my cable, N2 of my cable. I need to start connecting the transmits over here to receives over here. Transmits over here to receives over here. So what starts happening is, in this case, the oranges and the greens are flip-flopping, the blues and the browns are flip-flopping. Yes, we are connecting all the sends on this end to all the receives on this end. That's what your crossover is doing, so I can connect like devices. Last but not least is a rollover cable. The blue console cable we use to connect from the back of our computer into a router or switch for configuration purposes. If we put this on a meter, it would be a rollover cable. And what basically happens is N1 is wired, 568B color code. The other end is wired opposite. I literally put the connector, the RJ45 connector on upside down. And I literally roll over all the wires to the other position. One goes to the 8 and so forth. So there's what a rollover cable actually ends up looking like. So there's the 3 common patch cables that you would deal with. Most of these are going to be straight through. You'll have a few crossover, and you as an IT person will have 1 or 2 rollovers. Maybe one in your bag and maybe one attached to your laptop kind of thing. They mentioned screen patch cables. This will become more common as we start moving into, 6A and Category 7 cables. In this case, I need to make sure that all my components are shielded. The patch panel, the port in there needs to be shielded. The outlet jack on the wall needs to be shielded. My patch cables need to be shielded. And that shielding needs to be terminated correctly so that I get rid of the noise instead of kind of acting as an antenna to keep the noise around the cable. I need to make sure I'm getting rid of that. They mentioned fiber optic patches at this point too. Really, in this case, there's really no patching, so to speak, for fiber optic, because really fiber optic, a patch panel is really just 2 connectors here. This is a passive device. The patch panel itself is like a connector where one cable run kind of plugs in here and the other cable run plugs in here. So it's almost like you're plugging 2 patch cables together, so to speak. My patch panel is just this passive connecting device. And here's another style of patch panel. And here's even another style. Okay, and this actually is kind of pre-wired for a breakout cable to come into here out to all the ports. There's another one there. As you notice, we have spaces to store all the spare cabling. And again, I do need to worry about the AB crossover connection for the user. As I'm connecting, I'm making sure that I'm doing the crossover for the user. And that's really Chapter 8 for us. Again, our patch cables we're going to dig into in Chapter 9 in more detail, and we will terminate them in Chapter 9. But as I said, the main focus of this one was patch panels, Chapter 8 patch panels.